it's your boy Mr. TSEBE, and today we'll be proving Pascal's rule. So they're asking us to prove n plus r, n combination of r plus n combination of r minus 1, which is equals to n plus r combination of r, whereby r is the element of natural numbers and then it lies on this interval. So we can just say, we can start proving from left hand side, and then we say that n combination of r plus n r minus 1. So this is the same as n factorial over r factorial n minus r factorial, this part, plus this part is going to be n factorial all over r minus 1 factorial, this part, and n minus this part, r minus 1 factorial. So this is what we're going to do. This is the trick. We are going to take this part of the equation, but without the factorial, and multiply it here. And then we are also going to take this part of the equation, which is r, and multiply it there, so that we can have common denominators. So this is the same as n factorial multiplied by this thing is the same as n minus r plus 1. We are not taking the factorial, and then we can add n factorial, we multiply it by this r. We are not taking the factorial, don't forget, guys. So this is our denominator. Now you can see it now. This is our denominator. So since we took this and multiplied to n, I mean this part, since we took it and multiplied to n, we must also multiply it on the denominator. So we are going to have r factorial n minus r factorial, and then multiplied by this part, n minus r plus 1. This is the thing, sorry. So even here is the same story. N factorial multiplied by r. So, but our denominator is what? Our denominator is r minus 1 factorial. But I must also multiply by r here, because of I'm doing the same thing that I did here. So, and then I'll be having this part, which is n minus r plus 1 factorial. So this is what I'm having. This is what I'm having. But r factorial n minus r factorial, I can just write r factorial. And also on this one, r minus 1 factorial, I can just write r factorial. On this part, I can just write r factorial. So since we are on this step, this is what we're gonna do. But we can see that this is by substitution. We can substitute. This would be n minus r plus 1 all over this part. I said we can just write it as r factorial. It will be r factorial into n minus r plus 1 plus n factorial times r all over this part. I can just write it as r factorial. So I will be left with this part, which is n minus r plus 1. So right now my denominators are common. I can say n factorial n minus r plus 1 plus n factorial times r, and I can divide it now. I can divide it by my common denominator, which is n minus r plus 1. So if you can check here, we are having a common denominator, which is n factorial. So this will be n minus r plus 1. Also with this r, I'm adding this r here, all over r factorial n minus r plus 1. And this can be written as, this part, it can be written as, but if I add r and r, they cancel out. So I'll be left with this part, n plus 1, which is n plus 1. And then I will divide it by this part, r factorial n minus r plus 1. This thing, it can be written as n plus 1 factorial all over r factorial n minus r plus 1, which is the same as combination of n plus 1 r. And right now we have proven that LHS is equals to RHS. So if you enjoyed this video, you can join us to the next video, which will be part 2 of this Pascal rule, but we are going to be using Pascal triangle.